Hello, I'm Brandon McMillon, and I am a program manager for Whistler Application Compatibility, and that is what we will be talking about today. Our agenda starts off with what makes an application incompatible. So, what are all these different references that have happened, and what are the changes that occur when one operating system ships to the next that causes an application to go from working to not working? Then we're going to talk about how compatibility is improved in Whistler, meaning how we can make sure that the customers don't see those applications going from working to not working. They have their old operating system, they move to their new operating system, everything continues to run just fine. And then we'll talk about how we test line of business applications, which hopefully means a lot to the people out in the audience. We'll talk about app SWAT visits, which some of you may have been a part of in the past, and I'll give you an agenda and hopefully you'll be interested in it this time around. And then we'll finish up with a Q&A. So what makes an application incompatible? Well, there's the legacy issues. There are a lot of applications that people still use out there that were written for Windows 3.1, even DOS. Applications written in the mid-'80s or late '80s that a corporation still depends on people using. And then there's the changes in the operating system. Microsoft changed something, and now the application doesn't run. We run across this a lot because we find bugs during the development cycle, and in general, we can estimate how tough the fix is, and then we can fix it, and then we can do some testing, and we find out that perhaps this particular change breaks an application. And then it goes to the trade-off stage. A bug might mean that the operating system in general is more reliable, but it's broken an application that we know is important to our customers. In the NT OS, and continuing on with Whistler, we've always made the choice in the past that reliability and stability of the operating system outweigh the application. So we would make the change, we would fix the bug, make the change, break the application. In Windows 2000 and in Whistler, we'll work around that by fixing the application as well, just with a little different technique. And then there's application stability issues. An application has a particular problem that gets exposed through the OS. It worked on Win9X, was fine on Win95. This heat problem didn't occur, the application didn't crash. But now with Whistler and Windows 2000, we have a new bug that we found. There's platform differences. Many of these apps, as we all know, the API sets from Win95 to NT have some differences. And these can cause problems for applications. When the application was written, maybe the NT APIs weren't out there, or maybe they were just targeting Win95. Well, it doesn't really work for our customers to say, oh, sorry, this won't run on NT. We have to figure out ways to fix this. And then as much as we would like to categorize everything into its own small, tiny bucket, there's always the miscellaneous issues. This hodgepodge of issues that we run across that we can't really put our finger on. We still have to fix it, but we don't see a commonality between a lot of applications that share it. So our job is application compatibility. I think the key for this is to realize that compatibility is not really what we care about. It's the application incompatibilities that matter to us. If an application works and we're testing it, that's wonderful. Everybody's happy. We continue to test it. We look for regressions. We dive down deeper into the application. We keep it through the entire testing cycle. But really, Dev and PM doesn't get actively involved until we find those incompatibilities, until we find the bugs. And that's when we start looking at how to fix things. So what makes an application incompatible? Well, our number one banner issue is that the application refuses to install. It basically can start up and set up and complain about any number of things. I don't have enough drive space to install my files. Your particular operating system isn't supported on this application. You need DirectX, and as we all know, NT doesn't have DirectX, so I'm refusing to install. The operating system has changed our functionality, like we mentioned before. When we came up with a specific issue that was stability and reliability of the operating system versus causing an application to continue functioning, we always went for the stability and reliability. We didn't kick those applications off into the abyss. We just found other ways to fix them so that the operating system code was clean, pure, and as good as we could make it, and those existing legacy apps would still work. A change in the operating system has exposed a bug in the application. Now, this looks a bit the same as the previous point, but it's really not. This refers more to the points where, say, the older operating system would let an application get away with an unideal implementation, or potentially what some would view as a flat-out bug. And now, in a later operating system, that bug is being caught and bubbled up, and we have the problem. I think the most common example of this is probably parameter use on APIs. We would see parameters get filled in with garbage values when they weren't being used, and then later on, by random chance, that garbage value tends to be, or happens to be, something that the API looks at and says, oh, okay, I'll apply this to the new output, and boom, we've got a broken application. And then finally, there's the platform differences. Win9x and NT are not the same. DOS and NT are not the same. There are these changes as we move from platform to platform, and we still have to support the applications, but the changes are there, and they're breaking the apps. So what I'd like to talk about now are some of these most common concerns. What are the items, what are these problems that we see that happen across a broad range of applications? Well, again, number one with a bullet is setup and installation. The application will not allow itself to install on the current OS. In the case of legacy apps, in the case of a new operating system with these legacy apps, none of these apps were targeted for this OS. They were written at a time when, even last year, NT4, SP3 Plus were out, and Win98 was out. And that was their target. They didn't think about Windows 2000. They didn't care about Windows 2000. They sure didn't think ahead to Whistler. So they had some improper version checking. This is basically one of those things that we could have avoided, but we didn't, so now we have to deal with it. The application looks for very specific platforms, such as, am I on NT4? If so, install. If not, sorry. Well, Windows 2000's NT5. We don't work now. The setup fails. Tells you to please, cannot install this application. Please move on. The operating system is not supported. Well, this happens on more applications than you'd think, and it's been pretty common. We've seen it throughout the history of Windows. Every time we release a new version of Windows, we find some improper version checking apps. And so we've always solved it in the past by kind of fudging to them a little bit. We tell them that, oh, never mind, you are on this operating system that you want, because we know that the applications work without that. The second problem of setup and installation tends to be that people think of an operating system as a set of features, and they tend to look at that as written in stone. NT will never have DirectX in it, but this isn't true. They might need a component, but because they need that component, they shouldn't assume which operating system they will work on in the future. By not assuming that DirectX will never be on NT, by just checking for DirectX, which a lot of applications do, those applications continue to run on Win 2000 and work fine on Whistler now. If they assumed that they needed the Win9x platform, then we had a setup error that we had to go and fix. Another problem with checking components was people assumed hard-coded paths. They assumed that a particular DLL would be in a particular path and that this was unflinching and couldn't change. And that's just not true. There are system variables that allow you to get that information, And you really shouldn't just depend on where a registry key is or where a component DLL is. Use the system for it. There's APIs that exist there, but they haven't been, so now we get to clean up the mess. And the solution, just check for the functional component you need. If you need MAPI, if you need TAPI, if you need DirectX, check for its existence. The APIs are there. If it's an installation, it will tell the user if it's missing. The operating system informs the user. It then gives them the ability to install it. Security issues. You're going to find that a lot of your applications require admin rights to install. This is because of security changes that were made in the Win 2000 timeframe and are continuing on to Whistler. This is our one problem that affects a lot of applications and we have chosen not to fix. So why didn't we choose to fix it? Well, we could. There were some pretty elaborate schemes that were thrown out there for being able to work around some of the problems. But when it came to mucking with security, we decided that a hands-off approach was best. None of the apps are unusable anymore. They just require a higher security context than we are recommending that applications currently have. We believe that any user should be able to install an application for their personal use, and that's possible through Win 2000 and Whistler. You can't, but the normal user cannot write to program files, and they can't write to HKey local machine. They're writing to current user, they're writing in their particular directory, their personal directory. A lot of applications didn't support this, though. They expect applications install, wants to put things in program files, wants to write to HKLM. And so you need an admin right, you need administrator rights just to be able to install the application. Past that, also when they launch, they will tend to try and write to HKLM during the particular instance that the app is running. And that means that you have to have at least power user rights. So even past the install, you can't run the application. You're completely hosed until you move your user up to power user rights, and then they have the ability to run the application and everything seems fine. Again, we found ways to work around this, we found ways to fix it, but it's still a security hole. And rather than fix up the application so that the user doesn't see the problems, we want administrators and we want the IS departments to realize that continued use of those applications will require granting access rights to users that are not the default security context. And this is really the best way to evangelize it. Heap management. So this isn't a Whistler problem, but it continues to affect Whistler apps. As the NT code base comes out more and more and is used by more and more people, we're going to find more and more of these applications that run across heap problems. The problem started in NT4 SP4 when we introduced a new heap manager. It is an incredible speed increase. Basically, we changed the way that we reuse freed blocks. Now, when you free a block, we're using it near immediately. And while this resulted in a large speed gain, we found that it has exposed quite a few bugs in applications. Now, these are just implementation details. No APIs were changed, no application usage has been changed, but it's exposing the bugs because in the old days, you could free a block and, well, perhaps you use it for a few instructions past that. And then it really gets freed by the OS. But if you're requesting blocks, you were getting clean ones because those ones that you just freed were still off in the heap somewhere. Now, that's the first block we reuse. If you free it and then you create, we're reusing that block immediately and we run across access violations. We have workarounds for this. We have tools available, one even shipped with Windows 2000, that allows you to revert back to the older NT4 heap manager. It's still not quite the it's still not quite as lenient on you as the Win9X heap, but a lot of the applications ran on the older NT4 heap, and perhaps there would be a crash after some extended usage of time, but it wasn't immediate, which is probably what you'll see if you have a problem like this on Win2000 or Whistler. Hard-coded paths. People expect things to be places. On Win9X, there was the My Documents tree. Applications were hard-coded to pop right to the My Documents and try and save files to it. On NT4, we moved it off into the Win directory, profiles, then you would have a username and then personal. A lot of applications recognize the difference between both of those. However, for Win2000 and Whistler, we've changed it yet again. We have documents and settings, then the username, then a My Documents directory. Applications that expect things to be in places, they expect these components to be in a certain place, they expect a folder to exist, they expect a registry key to be at a certain path. These are the types of problems we run across. There are APIs, there are variables to get this information, but when an application doesn't use them, we tend to run across these incompatibilities. Long file and printer names. This has been a big deal for us. The average path length has increased significantly. I think the two most common examples were the personal folders. It used to be My Documents. Then it became a little longer in NT when you went off into the system directory. Now, with the documents and settings, username, My Documents, and profiles thrown in there as well, you end up with a pretty long string. Temp directories. Lots of applications expect C:temp as their temp space. We now have the temp directory under Windows, and I think it went from roughly like an 8-character string to something like 42. So if someone expected, oh, okay, applications expected long names, but they've still run into problems as we've increased long names even further because they would allocate a certain size for their string, and then when we overrun that, you hit the problems. The key here is just solid programming practice. Check your buffer length, find out how long the path name is, increase the buffer size as necessary. This seems pretty obvious, but it affects a lot of applications. And that's really what we're talking about. We're talking about small changes, assumptions you might have made that cause problems. Large drives, very, very common issue on setup as well. We can have easily 4 gigs of free space with the new 20 and 30 gig drives people have. Well, if an application was coded in the Win95 time frame, chances are 4 gigs was the only size that they used. They used a 32-bit number to define how much space was going to be coming back. And now, with more than 4 gigs free, they end up with some really odd number and probably a negative. There are negative 15 gigs free. The application then says, oh, sorry, I don't have enough space to install, and setup is aborted. So you can do a few things about this. We obviously have a recommended fix that I'll talk about in a second. Or you could do things like fill up your hard drive with files, which we've had people do to work around it. But we have some better solutions than that. So we've talked about all these problems. Well, how are we improving this compatibility? All these problems we just talked about, except for the security fix, how have we solved those? How are we going to continue to solve the new problems we run across? Compatibility with Whistler. What does it mean to us? Well, I say that application compatibility is a major goal, but that's a bit of a misstatement. It's, depending on the list you look of what our goals are, it's one of the top 3. Moving from number 1 to number 3, again, depending on which particular list you look at. In the Win2000 time frame, we had Steve Ballmer, our fearless president, say that an OS is defined by the applications that run on it. Nobody's installing Windows to play with Notepad or Hearts. People are installing Windows because the applications that work on Windows are superior to the applications that run on other operating systems. So getting these applications to run is our key to success. So in the Windows 2000 timeframe, we did a lot of work to improve the compatibility on NT. Well, Whistler, with the targets that we have for Whistler, we couldn't just be happy with the Win 2000 level. We had to continue it, we had to extend it, we had to move far past it. So our strategies used during the Windows 2000 cycle, this was really helpful because NT had never had such a concerted app compat effort. We tested a broad sample, hundreds upon hundreds of apps, shrink-wrapped applications, line of business applications, server applications. They were tested daily and weekly. We went through cycles. Get that set of applications done, test them all again, find out what we regressed, dive down deeper, keep going. We started working very closely with the ISVs to resolve the issues. We started regular contact between the actual product group that was dealing with these app compat issues and their counterparts that were working in the companies that these applications existed. We ended up having to develop the technology that allowed these existing applications to work on the OS. We couldn't allow the operating systems to support these applications, as was done in the Win9X days. We had to have some new technology so that the OS could be as good as we could make it, and the applications would still run. And we focused on client apps, in general business productivity. We did some entertainment and we did some home apps, but that wasn't the Win 2000 target. Server applications were very important, and the international ones as well. So of course we learned a lot of lessons. The first was that we were essentially confronted with a chicken or the egg problem. Which comes first? Our ISVs would tell us when we contact them about a particular bug, well, you know, this seems like a serious bug, but we haven't had customers really we haven't had customers tell us about this. We haven't had customers say that they want to use this application on Windows 2000 or on NT in general. And at the same time, we have the customers saying, well, we're not going to install Windows 2000 until these applications work. So if the ISVs are unwilling to ship a patch to us to fix the application because there's no customers, and the customers are unwilling to join until we have a patch for this, we ended up with a dilemma. And we tried talking, tried sorting it all out, and it really came down to the final goal and realization that we have to drive the compatibility effort. We can't expect ISVs to patch their existing applications. For cost reasons, a patch is expensive. They have to distribute it. They're working on new versions of their product. Those are the key. A lot of times we tell them about bugs and they fix it in the latest product, but they don't go back to the 3 and 4 versions in the past that we still have significant customer numbers using. So we're driving the effort. We're fixing everything. We're making sure it's right. And that solves our problem. Well, how do we fix these problems? We came up with a pretty short list for requirements. We felt like they had to work on the API level. In the Win9X days, an application fix had been targeted at a particular app. And we didn't feel that that was necessarily the best thing. We felt like that if we could take these fixes and make them small and modular, if we could take the individual bits that have problems and fix those, then we would end up with a much more reusable framework than we would have in the beginning. Rather than cranking out some code that fixed a version of Director or Netscape or Corel, we would look at the problems that programs commonly have. We would fix an app, or we would customize a fix for a particular problem, and then we could use multiple fixes to fix a particular application. So if a particular app has, say, 5 bad calls in it, we can use 5 separate modular fixes working in unison to fix that application, rather than special casing an app and then doing the code that fixes that. And we decided that we also needed to be able to update and distribute these very easily and conveniently for customers. In the past, we would get applications working on an OS, Win9X in particular, and then kick it out the door. And then the OS was the new standard. Applications that were shipped on the day after Win9X shipped were expected to work. Well, again, we've decided that we can't really hold to that model. We have customers out there using all the different operating systems, and the ISVs, while the applications are very important to our customers, the ISVs might not have the resources to test and make all these applications work on all our operating systems. So rather than follow the operating system's product cycle, we're going to continue on with work even after the operating system ships. We're going to continue fixing for Win 2000 after it ships. After Whistler ships, we will continue to take customer reports about bugs and fix these issues, ship those fixes. So our solution with these requirements. Well, we decided that in Win 2000, we needed an OS mechanism that allows these different fixes to be applied to applications as they're loaded, so that we can have the multiples and fix multiple problems with a particular application. And we didn't want it to be in the OS code base. We didn't want the APIs to have these fixes. This was played around with and done in the past, and we preferred to have the clean API code and then have our fixes external to the APIs but internal to the operating systems, or to the operating system. These fixes are reusable. They're components that we can essentially plug in as the application is loaded, and everything is taken care of. The delivery mechanism for this, we found that Windows Update solves most of our needs. Our fixes are very small. They're components that we're plugging into the OS, but an individual fix might only be a couple of bytes. Urgent fixes, we can publish these very quickly. We can have something out on Windows Update a couple of days after it's available. And the ability, Windows Update also has some very nice features for allowing us to group fixes by the application markets they affect. So Windows Update has these different market segments, such as consumer, which would allow us to package up all our game fixes in a particular package that could then be delivered. So the point is that you only get the fixes that apply to you. We're not throwing in the fixes for Quake if you're a business house. We're not giving you things you don't need or don't want. And then also we've made tools available. One of them shipped in Win 2000. We're going to have a much more expanded, improved version that will be shipping in Whistler that allow you to apply these fixes to applications that Microsoft might not test itself. How did this all shake out? Well, with the ISVs and the customers, the ISVs are very pleased with the current situation. They cooperate with us to produce these app fixes. They might not want to patch an application themselves, but their devs are more than happy to look through their code, figure out what the problem is, talk about the assumptions they made, and what we need to do to fix this. Their customers are satisfied, so their support worries are gone. This is what makes them happy. They know that their customers, if they choose not to upgrade and get the new features for a new application they're producing, their customers aren't going to complain to them. They don't have to worry about the phone calls and the complaints. And they also lost the cost of publishing a particular patch. The customers obviously are overjoyed. They don't know that anything was ever broken. They don't know that anything was ever wrong. They loaded their app. It just works. Who cares? So how do we hit this nirvana? Well, as I talked about, we're still testing all of these applications in-house. We're still doing all of these things. In Win 2000, we started playing around with the idea of an app SWAT, and that was line of business application testing. We knew that line of business apps were very important to us. We knew that we had to do something about them, but we weren't terribly sure how to do it. So the app SWAT became an idea of, let's create a small team, send them out on site to these partners, and JDP partners tended to be, I believe, the only people that we sent app SWAT visits to the last time. And we just do in-house testing of a ton of applications. So I'd like to talk about that so that the JDPs that weren't involved in it last time, you can see are you interested in this? Does this make sense to you? We're focusing on our line of business applications. We tend to have the MCS relationship in place. We use these MCS to determine what our focus is. What does this particular corporation care about? And what do they feel needs to be addressed? We would send in a dev team member, potentially a couple, so that we could debug the issues right there. We would send in other team members, test and PM. We would have them set up machines, talk about the different, give talks on particular technologies and problems. It was pretty much a self-contained extension of the App Compat group coming to visit. We leveraged the MIS developers for those customers where we could, bring them in, have them talk to us about the problems. And then obviously we don't know these applications, and it takes a while to come up to speed on an application. So we were asking them to bring in their users to test it after setup so that we can really do the kind of scenarios that we would expect their users to do. We formulated a specific 5-day approach. It was 1 week. There were reports for the individual applications. There were reports and forms on summary wrap-ups. We expected lab setup instructions. That was very important from us. We ran into some snags there. And these bugs were filed straight into RAID. This was not we get the information and move on. Everything's going straight into RAID, and it's being looked at by the Windows team immediately. We had daily status reports back to our management as well as the JDP management. And then we had a summary report sent to the App SWAT manager. Again, our methodologies tended to be the exact same as what we do in-house. We took a typical test matrix, which would be a clean installation, and then we looked at the upgrade scenarios that were important for that company. In Whistler, we tend to test every upgrade scenario. Every release of the operating system has an upgrade scenario, and we test that for a particular app. But it doesn't make sense to do that at a corporation if those releases of the operating systems are not available or not important. We had at least 1 machine, and we prefer to have a few machines for each scenario. That tends to help us localize problems to various hardware, to potential component setups. And then we have a company contact, someone there that's right there with us that can explain the various problems we run across. Again, we're in an unknown environment and we need your help. We create the record of the applications we've tested. Lately, we've even gone so far as to incorporate those applications, try and incorporate those applications into our library. We find out what the upgrade scenarios are. We find out what language was used to write apps. We find a lot of the runtimes have specific problems that we know about that we've already fixed in other applications, and those applications can be fixed because we know the runtime has a particular problem. We don't have to have the source code for it. We just need to know what it was written using. And then we document any plans in place to upgrade the applications. Again, this is so that we know we're testing the right thing. And then we document the matrix of results so that the partners that we're at and our internal team can see how we did. Of course, there's always some to and from in this. We always can be a little flexible on it. Sometimes we have to do client and server in parallel. Sometimes we have to speed up. Sometimes we send more people. Sometimes we send less. It completely depends on the particular situation. Day one starts off very easily. It's an introductory meeting. We go through the lab equipment. We start identifying the people that we need, the resources you need, and we start identifying to you the resources that we have. We start off on client-side testing, and this starts off with a depth testing, and then we tend to move on to breadth. We have a daily results meeting, and then when we leave the site, we're razzing into Microsoft, reporting the bugs, sending out the status email so that we know what's going on. We continue our depth and breadth testing on the client side on day 2, and then we have yet another result meeting, exact same. It's just a continuation of the client. Day 3 is the finishing of the client side testing. Depending on the number of apps, client could continue on in parallel. It could have only been a day. Again, there's a lot of flexibility. It depends on what the company's situation is. Then we start our server upgrade testing on day 3. We start testing those verified and fixed clients against the deployed server, finish up with our daily results meeting, reporting the bugs, etc. Day 4 is the continuation of the server upgrade testing. Then we move on to the clean installations. Many corporations, and we were a little surprised about this, want to try the upgrade scenarios. They want to know, can I just upgrade my network to the next version of the OS and will it work fine? We had always expected the server upgrade scenarios to be completely a clean install, but we've changed our methodology accordingly. And then day 5, the last day, we wrap up any of the remaining problems. If we have to take an issue with us back to Redmond, that's fine. We get the resources we need. We also have a final test results meeting, and then we file the bugs and leave the site. So our bugs reported, let's look at some Win 2000 numbers. We tended to test 15 to 40 apps per site, again, depending on the company. We had 158 bugs reported from these app SWAT visits. 96.8 of those are closed now, 1.2 were resolved, and 2% are open. So we had 25% of those 158 bugs were new bugs that we then fixed. So we have results, we've made changes, and we've gotten these things working. A lot of the issues are proven common across the line of business apps. The runtimes, we ran across several problems with runtimes, and runtimes seem to be, many people use VB, Delphi, etc. We can fix those. We can move it on. One particular bug fixed that's listed on the slide might affect 50 applications or thousands, depending on which particular runtime was fixed. And then we also found that as we went out into the field with later builds of Win 2000, the bug rates dropped dramatically. And as we fix those first issues, it's the exact same thing we saw in our testing of the ISV apps. We had these common issues, you fix them, then you can apply the fix to other applications, everything's working. Well, we obviously learned a few lessons. Get a firm commitment of time and resources. We would love to have people do app SWAT. We would love to have people volunteer for app SWAT. We're not too sure how exactly we're going to use it in the past or in the future. In the past, we looked at it in the very beginning as this will be something that we can guarantee that every corporation that matters to us has something that works. They can get a little time slice of a Microsoft development team, and that we can go in and make sure that everything is fine. But as the results came back, and we started finding that we can fix a lot of these applications by using a few good examples, we cut the program off a little bit because we weren't finding the new bugs later on. In the future, the current plan is to, again, elect some representatives Find some of these people that have very common network setups, that have different run times that we can test. And we're going to go to those places with the same app SWAT effort and fix them. But we're not sure that we're going to continue to do every corporation that says so. It might turn out with the results we receive back that we do quite a bit. May turn out that we don't. Where some of the resources, again, this is just to give you an idea, some of the resources we're going to expect. And let us know if you're interested, because we've already started some up for Whistler, and we'll continue, especially as the early adopter program folds out. We're going to continue to pick up app SWATs. We have to have adequate hardware. We have to have a full-time liaison. So this is one person's time for the amount of time that we're there. We need the ability to involve the users in our testing, because that is the only way we can get the time that we need, or the scenarios tested that are important. We also would like to determine which server-side applications can be duplicated in our labs. We have some pretty extensive labs. We have large amounts of hardware. But the server-side applications, are they portable from your environment? If they are portable, it's really easy for us to move them into our lab, test them for you on Redmond, report back with the results, package fixes, etc. If they're too complex, though, we're going to have to look at coming on site. MCS contacts are very important to us. Make sure that your MCS has the time to be there when we're there. And then we've also, Y2K testing was something that got in our way a lot, and I know a lot of corporations are still continuing it. If there is some continued Y2K testing, or some large amount, okay, well, this week we're rolling out, we would prefer not to be there at that time. It tends to be a drain on the resources, and the departments, everybody has limited resources, and we would prefer to be the focus and be able to get the attention that we need when we run across these issues, because we're not there for very long. Debugging itself, finding the right problems, some of these issues take a couple of days, and we're not given much time. We have to have internet access from the testing area, and this is so that we can hook back up with our peers in Redmond, talk to them, find out answers, have them remote in and debug, which we've done frequently. The operating system is a large code base, so we might not have the particular expert of that area on site. And then one thing that we've also chosen is a lot of people focused on desktops and servers. And we found that the upgrading of the laptops was also a nice scenario. So just know going in that upgrading the laptops, if we could have some executives or the people that carry laptops included in the scenarios, that would be very beneficial. With some corporations, particularly the larger, multi-language versioning became a very, very important endeavor. We test these in-house. We do lots of language issues. We have our language fixes. We would like to test that on site as well. We will bring to you a list of the resources. And so how do we finish up? Well, this is the call to action. What do we need from you guys? Well, we need to know what applications are important to you. We're testing these every day, and we have our list based on market data and usage and sales over the last ever how many days, because we move back different years with different weights. We have polls. We look at the amount of bugs that come in. There's all these things that we look at. And we've asked the JDPs in the past, I believe, or most all the JDPs, for an application list. Update that list. Send it to us. It goes right to us. We find it out. Then we incorporate that into the applications that we test. Maybe your line of business apps aren't in our library, and we can't test those automatically. But if an application is very important to you and you have a specific number of seats that are associated with it, we can put it on our daily testing lists. Application compatibility, and I can't stress this enough, is the outcome of testing applications early and often. If you start off with a strong plan and you follow through on it, everything's going to work. We can solve these problems, we can figure them out. The sooner the better. You won't have rollout problems, and things will move on, and you'll wonder what the big deal is about changing operating systems. And then the final call is encourage your development groups to start testing now, even if they're not sure when you're going to deploy. Again, getting the information to us as early as possible is far better from a development standpoint for us. We can find out these problems that we're having, start seeing the commonalities, and get the fixes before they ever matter to you on a deployment. And that completely changes it from an emergency-based to a the app fix was waiting for us. Okay, so now I guess it's time for some Q&A.
We've got 2 questions waiting for you.
Okay. Should I read out the question?
Yes.
Oh, okay. So this question is from Andrew Ferguson. We had an app SWAT team for Win2K, very successful. Is there any way for us to continue this work internally? Any templates for generic testing methodology? We had too many apps creep out of the woodwork after the app SWAT team had visited. Okay, so I didn't cover this particularly in depth on the slides, but examining the upgrade scenarios, and then we found that there's really no way to test an application except to go through the users. Have your users, if you could have a small branch of users that it's rolled out to, have them try it out and have direct access to the developers to report problems. We've tried testing applications in a lot of different ways, and it really comes down to you have to do the black box test, go through the user scenarios, and find the problems. There's not so many. There's not really the magical tool that goes and finds the app compat problems. They tend to be a little too deep. Again, you can contact us. One of the email alias, and there's several that exist. One of our new ones is appfix, APPFIX, @Microsoft.com. There's most of us application compat people are on the list. And when you have questions like this, feel free to send them on to us, and we can. I'm sure I can send you generic test methodology for AppSWAT if you contact appfix @Microsoft.com, because we have some documents on it. And another question is David R. Bergstein. Can we expect that Windows 2000 certified applications will run on Whistler without issues? If not, what exceptions apply? Okay, so that's tough. I would say that a Windows 2000 certified application, yes, it will run on Whistler without issues. The types of things our certified apps were supposed to do, the types of technology they used, have not changed. They should have made it past several of these problems that I talked about and thus not be vulnerable to them. What exceptions apply? I think this falls into the miscellaneous. Anybody can come up with something that we can't possibly track. Their code is a living, breathing creature, and there's no way to completely guarantee, okay, we know that this is going to work wonderful because we've tested X number million lines, and we know that everything's fine. And I'd like to thank everyone for their time today, and thanks for the questions. Again, appfix @Microsoft.com, and I can follow up on anything you have later. Bye.